Hello and welcome. Today I am excited to share this interesting tool that I have developed for analyzing and understanding and applying the chi-square distribution in finance. So in this app I have three tabs: PDF of chi-square distribution. So let us start with this tab where we study the PDF of chi-square distribution. I'm scrolling down and here you see that this is the formula of PDF of chi-square distribution. Let us try to understand the formula. Here in this formula, we have the function of x given degrees of freedom, which is equal to, and this is explained by this formula. So we will divide this formula into certain parts for understanding. X, in the context of, say, portfolio variance testing, we are taking one example, right? In order to understand the chi-square distribution, we have to take one example, and we decided to take portfolio variance testing. There are some other applications also which can be made for this distribution, chi-square distribution in quantitative finance, but we will talk about that later, right? In portfolio variance testing, X would represent the observed variance of portfolio returns, calculated from the historical data. For instance, if portfolio's actual variance comes out to be 2, then this would be the value of X, and this we will enter here, right? Specific value of X. So this is the input that goes into this web app, which is plotting the PDF probability density function of chi-square distribution. So then DF is of course the degrees of freedom. We all know, we have heard this concept. This is number of observation minus the numbers of parameters estimated. Suppose you have 10 daily returns observation and estimate one parameter, right? That is mean only, then the degrees of freedom would be 9. So here in this app, the degrees of freedom are taken on this slider and they are 9, right? So we have entered X, we have entered 9, and dynamically this app is showing us the PDF probability distribution, probability density function, I should say, at that particular value. So at 10 it is this, right? If we go vertically, but at 2 it is coming out to be very close to 0.158, and this is shown here also and on the graph also. At 2 it would be 0.0158, right? So this way. But in this formula, we were talking of the formula, right? In this formula, this is a normalizer of the distribution, right? Here we have 2, right? Which is raised to the power half of the degrees of freedom, right? This is a normalizer function. That is what we call it. And this second part, this one, right, is gamma function evaluated at half of the degrees of freedom, right? So it generalizes factorial of non-integer values and ensure that distribution sums to 1. So this is used for that. Very interesting, the gamma function. And this part of the distribution where we have X raised to the power of half of degrees of freedom minus 1, right? This part is another part, and this last part is where we have the exponential term that decays as X increases. That is interesting thing. It reflects a probability distribution, probability density of observing larger values of X. So this would be helpful there, right? So in our situation, in our finance situation, if we are applying this distribution, chi-square distribution in testing the portfolio variance, right? If we are testing it against, say, specified benchmark of 1.5, right? So benchmark is that variance should be 1.5, right? But our observed value is 2, right? And our degrees of freedom are 9, right? Then the value of having variance of 2 is 0.0158. So this web app is very interesting tool and dynamically lets us select the value of x. Here I can change the value of x maybe to say 9 here, and then you see that probability has increased and it is 0.0923 here, 0.0923 at approximately 9, and degrees of freedom are also 9, right? So this way, this is dynamically adjusting of the values of degrees and freedoms and x, and it would give us the probability density function. It just means the exact probability of having a variance of 9, or if I want, I can have a value of 4, and then this is that probability. The probability of having a variance of 4 is 0.0658. So this is an interesting app. In another next learning, we will talk about the applications of chi-square distribution in finance in various situations. See you later.